All right, the reason why I picked this question for us is because graph questions come up really often in the HSC. They come up either every second year or every year. It's usually 4 or 5 marks on the table that are pretty free, right? And like graphing is like a universal skill, so it helps you in chemistry and physics as well. It's a skills test, so who knows if there'll be a graph question, but graphing is a skill and it is accessible, which is why I am helping us do it now. And I'm just going to assume it's worth 5 marks. So we've got a table here detailing the rate of cellular respiration of seaweed at various temperatures. I've got what's the word for this? An abbreviation thing. Is there a proper word for it? I actually don't know. Acronym, that's the word. Yeah, acronym. I've got an acronym, right? Salt and pepper, right? So scale, axes and units, labels, title, and plot points, right? So I've already started filling the chart, but I'm just going to tick off as I correctly fulfill these requirements, right? So firstly, I can see that I have a title, right? So this is done. Plot points I'll do last. Now labels refers to like the labels here on my axes, which I have done. So I will tick that off as well. Axes plus units. The units is just making sure you include your units from the table. So in this case, it was milliliters per minute for the y-axis and degrees Celsius for the x, right? So I've done the units component. Axes can be a bit tricky. How I like to remember it is there's 2 ways. Independent should go on the x and dependent should go on the y, right? So can someone tell me what the independent variable is? Yeah, it's a temperature. Yep, that's because the independent variable is what we're changing and the dependent variable is what we are measuring. Okay, so the easier way to remember it is the stuff on the left side of the table, so the left column. This should generally always be the independent variable, right? And the stuff on the right is always the dependent, right? So that's why I put temperature on the x and CO2 produced on the y, and that ticks me off for axes. Now scale, this is pretty simple, but you guys are in year 11 now, so it's not uncommon for people to throw a little wrench in the works for your graph. So you can see here, we go up by 10 every time, and it's pretty normal. And then we go up by 7, and then we go up by 5. Oh no, 15, right? So this can happen, but it's important that even though your table data is a bit strange, you should still keep a consistent scale for your graph. Right, so what that means is, even though this next point is 37, I don't write 37 here, right? Because that means my scale at the bottom of my graph is now completely incorrect, right? Because I've gone up by 10 each time, and now I've gone up by 7, right? And this will lose you a mark in the exam, right? So what you need to make sure is that you keep a consistent scale. So I'm just going to go 30, 40, 50 and 60, right? So now I can tick off the fact that I have a good scale, and then I'm just going to plot my points, right? So let me just bring it up. I'll plot it quite quickly. Okay, 10 is 3, 20 is 7. This won't be a perfect plot because I'm just going to go very fast for the sake of time. 40 is 37 is 12. 52 is 5. 60 is 1. All right, now I've plotted my points, so I've satisfied my criteria. The last thing we need to do is figure out what kind of graph we need to draw, right? So generally we're working with 3 graphs in science. It's either a column graph or a scatter plot, or it can be a line graph, right? Now to determine which to do for which table of data, we want to look at the numbers themselves, right? So I always say if there's one categorical piece of data, so one category, and one numerical piece of data for the table. Then I draw a column graph. But I can see here that both my data sets here are numerical, right? So I should either be drawing a line graph or a scatter plot. Generally, if you just draw a scatter plot, you'll be fine. The only instance where you draw a line graph is when you want to measure the change over time. So when your independent variable is time, right? But in this case, our independent variable is not time, so we don't need to draw a line graph, right? But honestly, most of the time, just draw a scatter plot, right? So if I draw a scatter plot, obviously, if I'm looking at the shape of my graph, should I be drawing a line of best fit here or a curve of best fit? Yep, a curve of best fit, right? So I'm going to do my best. This might look pretty bad. In the exam, if your curve is like a bit cooked, it's fine. As long as it hits the main spots, it's okay. So, all right, something like this. This is just the first try. Use a pencil, right? Now, the one thing I want us to note from this curve is I don't start it from 0. Why don't I do that? Exactly, right? If I don't give a 0 data, I do not extrapolate my curve. The only time where you should extrapolate something is when the question actually asks you to. If it doesn't ask you to, then you don't need to, right? What if we were asked to refer to a point on the graph and then mark it? Do we know how to do that? No? Okay, so let's say, for example, a question asked me, what would the value be at, let's say, or the value be at 40, right? So how I would do that is, if they ask you to annotate it on your graph, you should be drawing a dotted line. Oh, that is weird. You should be drawing a dotted line all the way to where your point intersects, and then a dotted line to the y component as well, and then mark it with another dot or a circle. It doesn't matter which one, right? But this is the accepted notation for how to draw a graph, right? And now once I've done this, we should never lose any marks in any graph question ever again. Okay? No pressure.